Alright, so in this video what I want to do is I want to find the area bounded above by y equals to negative x squared plus 5 and below by y equals to 1. So let me actually try to draw this so that you can get an idea of what the picture looks like. Okay, so here we have the graph. We have the graph right here of y equals 1, right? So that's below, and above we have the graph of y equals negative x squared plus 5. So it is the graph of the function y equals to negative x squared raised up 5 units. So we go 1, 2, 3, 4, and 5. So we want to find this the area bound by these two graphs. So what we need to do is actually find out where these two graphs intersect. So they're going to be intersecting here, right? So we got to find out those two values. So we have to set up an equation between this and this to actually determine the two values, the two x values where they intersect, and we will do that. So I'm going to set up the equation negative x squared plus 5 equals to 1, right? So this equation, and now I solve this equation for x. So what this implies is that x squared, right? So this implies that x squared is equal to 4, and consequently this implies that x is going to be equal to plus or minus 2. So this implies that x is equal to plus or minus 2. So that's where the two graphs intersect, okay, when x equals to plus or minus 2. Alright, so those are the x values where they intersect. So what I'm going to do at this juncture is I'm going to do an integral now. So this is above, this is below. So what I'm going to do is I'm going to subtract from the area under this graph, under y is equal to negative x squared plus 5, the area under the graph y is equal to 1. And then what I'm going to do is well, compute the integral, and that will give me the area that I'm going to shade right now, namely this area, right? So let me actually get started with that. Alright, so here I am. I'm taking the integral, and now, as I said, I'm going to take the integral from negative 2, x equals to negative 2 to 2, and the function is going to be negative x squared, okay, plus 5 above, minus 1 below, and I'm integrating with respect to x. Okay, so now I have my integral here, and now I have to evaluate this. Alright, so let me do so. Notice that I can simplify this, so this becomes the integral, this becomes the integral from negative 2 to 2 of negative x squared plus 4 dx, and of course this is going to be equal to the antiderivative of this, which is negative x cubed over 3, okay, plus 4x evaluated between negative 2 and 2, right? So what I'm going to do is I'm going to do this evaluation now. I'm taking this whole expression here, this antiderivative, and evaluating it at 2 minus the same antiderivative evaluated at negative 2. So let me get started with that. Okay, so I'm going to go minus parentheses, substitute 2 in it, and then cubed, and then divide this by 3, and then plus 4 parentheses, substitute 2 in it. So I have this expression here, which I have to simplify, and then minus this expression evaluated at negative 2, right? So I'm evaluating, so that's minus negative 2 cubed divided by 3, and then plus negative 2 times, okay, so plus 4 times negative 2, and here it is. So now I have to conduct this this simplification arithmetically, and see what I get. After simplifying this, this is equal to 32 over 3. Thanks for listening.